Now, let me concentrate little bit on this multi-objective optimization, which I have discussed in much more details. So, till now we have considered we have summarized like how to tackle the single objective optimization problem. Now, I am just going to summarize like how to tackle the multi-objective optimization problem. Now, these particular algorithms I have already discussed in much more details, and let me just try to summarize. Now, by multi-objective optimization we mean the problem having either 2 or 3 objective functions, and if it is more than 3 like 4 and above, we consider many objective optimization problem. Now, here our purpose is to find out the Pareto optimal front of solution if there are 2 objectives. Now, let me take a very simple example. Supposing that I have got 2 objectives f 1 and f 2, both are to be minimized, and our aim is to minimize both, but the reality is such. So, if I increase f 1, f 2 is going to be decreased and vice versa. That means, your f 1 and f 2 are going to contradict with each other. Now, if this is the situation, so there is a possibility that we will be getting this type of front, that is called Pareto optimal front of solution. And how to get? So, these are the methods like how to get this type of Pareto optimal front. Supposing that this is the Pareto optimal front of optimal solution. Now, this particular Pareto optimal front of solution is named according to the name of proposer, the Pareto. So, according to the name of Pareto, so this is known as the Pareto optimal front of solution. Now, on this particular Pareto optimal front of solution, so if I concentrate on a particular solution, it means one value of f 1, another value of f 2, another solution one value of f 1, another value of f 2, another solution like one value of f 1, another value of f 2, as if we are putting different weights on the different your objectives just to find out the optimal solution, and after that we are going to find out the locus of this particular optimal solution. So, this is the way actually we can find out the Pareto optimal front of solution. Now, if I concentrate on this weighted sum approach, almost similar to this we use a particular the method. Supposing that we have got in weighted sum approach, supposing that I have got 2 say objectives which are to be minimized. So, minimize f 1, say minimize f 1 and minimize f 2. So, this is converted into a single objective optimization problem like minimize W 1 multiplied by f 1 plus W 2 multiplied by f 2, such that the sum of W values becomes equal to 1.0. So, I can take W 1 equals to 0.3, W 2 will be 0.7 and vice versa. Okay. So, using this, so this 2 objective optimization problem will be converted to a single objective optimization problem and we can solve it. Now, here we consider only 2 objectives f 1 and f 2. Now, so there is a possibility we will be getting the Pareto optimal front of solution, provided these 2 objectives are fighting with each other, they are contradicting with each other. Now, if they are helping one another, so we will not be getting the Pareto optimal front of solution. Now, this is what we get if I consider 2 objectives. Now, if I consider say 3 objectives, we will be getting the Pareto optimal surface. The 3D surface we will be getting for this particular the Pareto optimal. Now, if I consider 4, so there is a possibility you will be getting something which we cannot visualize, and that is why that particular treatment of the multi-objective optimization problem has been given a new name, that is called the many objective optimization problem. Of course, this principle of many objective optimization problem I did not discuss in this particular the course. Now, then comes the concept of the goal programming. So, in goal programming actually what we do is we have got some target and we have got some calculated value of the objective. Supposing that the calculated value of the objective is say f I x and the target is say t I, we find out the difference, the mod value of that, and this particular the difference, the mod value of difference we try to minimize, and that is actually the goal programming. That means, for each of these particular objective function we will have to set the goal, and once you have set the goal, now you can carry out this type of goal programming problem, and you can find out the solution for this type of multi-objective optimization problem. Now, this is how to use the goal programming. Then comes your the vector evaluated genetic algorithm. Now, this I have already discussed in much more detail, and this is in fact the first application of genetic algorithm to solve the multi-objective optimization problem. Now, here in Vega, actually what we do is, supposing that I have got an optimization problem having say q number of objectives. So, what we do is, we take a large number of population, say capital N. Now, supposing that n equals to 10 and q equals to 10, n equals to say 1000. So, what we do is, we try to create some subpopulation. So, this particular initial population is selected at random using the random number generator for the GA. Next, what we do is, we try to create some subpopulation of size n divided by q. So, n divided by q is nothing but 100. So, this 100 subpopulation we try to form one mating pool like this, and here in this mating pool. So, what we do is, we create the first subpopulation of n by q corresponding to the only to the first objective function. So, we concentrate only on the first objective function, we get one subpopulation. Next, we concentrate on the second objective function, we get another subpopulation, and we get the last one objective function, we get another subpopulation. And after that, once you have got this particular mating pool, we do the suppling, and by doing the suppling, as if we are going to use the same principle of this weighted sum approach, as if we are putting some weights unknowingly, some artificial weights, and by doing that, so then we go for the crossover and mutation, and this process will go on and go on. Then ultimately, we will be getting a very good population of this particular the solution, which will indicate your optimal solution. But they did not try to get the Pareto optimal front of solution. Now, this is actually in short the principle of the vector evaluated genetic algorithm. Now, then comes your the distance based Pareto GA, that is DPGA. Now, here what we do is, so the whole population, that is the capital N, that is divided into two subpopulation. One is called small n 1, another is called n 1, another is called n 2. Now, on this subpopulation, so this n 1, the GA operators are going to work, and n 2 is nothing but a subpopulation of your non-dominated solution. So, non-dominated solution is actually a better solution. Non-dominated solution is actually a better solution. Now, if I compare and if I try to define the non-dominated, supposing that I have got f 1 and f 2 are two objectives. Now, my aim is to minimize both f 1 and f 2. I have got one solution here, say solution 1, and I have got another solution here, solution 2. Now, solution 2 is better compared to your solution 1 in terms of both f 1 and f 2, because our aim is to minimize f 1 and f 2, and that is why this point solution 2 is a non-dominated solution and 1 is nothing but a dominated solution. Now, here actually what we do is, so we try to update this non-dominated subpopulation, and the size of the non-dominated subpopulation is going to increase, and gradually you will find a large number of solutions lying on the non-dominated bin, and if you just plot them, so you will be getting some sort of Pareto optimal front of solution. Now, here there is one drawback of this particular algorithm. As the iteration proceeds, the number of non-dominated solutions are going to increase and we need more memory to store, and the GA will become slower and slower. And that is why actually this distance based Pareto, this particular DPGA could not achieve much popularity. Now, then comes the concept of the non-dominated sorting genetic algorithm, that is NSGA, and its modified version is NSGA 2. Now, here actually what we do is just like ordinary GA. So, you will have to consider the selection pressure and the population diversity. To maintain the selection pressure, we take the help of the reproduction scheme. That means, if you find some better solution, we give some preference in the mating pool. How to give that particular preference? This I have already discussed in detail. Supposing that, so this is the two objectives which are to be minimized. So, I have already got the non-dominated front solution, those are known as the rank 1 solution. Say we have got a few rank 1 solution, we have also got a few rank 2 solution R 2, we have got some rank 3 solution and so on. Now, during this reproduction scheme, the rank 1 solution will get much advantage because they are better in terms of the fitness. So, there is a possibility that in the mating pool there will be more number of copies of this particular rank 1 solution. That means, by doing that, so we can ensure some sort of selection pressure. Now, how to maintain the population diversity? Now, as I discussed that in NSGA actually what we use is, we use the concept of sharing just to maintain that particular the diversity in the population. So, what we do is, supposing that I am just going to find out the Pareto optimal front for F 1 and F 2, both are to be minimized, and I have got a solution, one solution here, another solution here, another solution here, and here we have got a few solutions which are very close to each other, and here I have got a few solutions. Now, if this is the situation, there is a possibility that, so these particular end points and these particular side point or the end points will be deleted from this particular your Pareto front, and consequently the Pareto optimal front, which was previously something like this. So, this will become only up to this. So, it will become squeezed, but what we want is a very wide Pareto optimal front of solution. Okay. And just to ensure that, and just to ensure the diversity, actually what we do is we take the help of sharing function. How to implement? To implement the sharing function, we take the help of Euclidean distance. The Euclidean distance between 2 points like I and j, that is d I j. Now, if d I j is found to be less than some pre-specified value, that is called the sigma share value. So, we give some non-zero value to the sharing. Okay. We give some non-zero value to the sharing. In fact, the expression was sharing was nothing but 1 divided by 1 minus d I j divided by like this sigma share, and I can also use the square term also I can use, there is no problem. If d I j is found to be less than sigma share, otherwise, so this particular sharing will be 0. Now, if this is the situation, so for these end points the sharing value will be less, and these points which are very close to each other, the sharing value will be more. Now, we calculate the shared fitness. Now, the shared fitness is actually nothing but the original fitness divided by the summation of the sharing, that is called the niche count. So, summation of the sharing value, the summation of the sharing value. Now, for the end points, the summation of the sharing value will be less. So, the shared fitness will be more, and for this point the shared fitness will be less. Now, we do the proportionate selection or the reproduction scheme using the principle of the shared fitness in place of the original fitness. And if I do this reproduction using the principle of the shared fitness, there is a possibility these end points will be selected in large in numbers. So, this part of the Pareto optimal front will not be lost, and there is a possibility we will be getting very wide Pareto optimal front top solution. This particular method has been used in NSGA, but it has got a few drawbacks. The drawbacks are like it is computationally expensive, and the user will have to define this sigma share value, and it is computationally expensive. Just to make it faster, the concept of sharing has been replaced by the concept of the crowding distance in the NSGA 2. In NSGA 2, so we can consider the concept of this particular the crowding distance in place of the sharing function. Now, here actually the way it is done is very simple. So, what we do is, supposing that I have got this type of, I have got one solution here, another solution here, another solution here, another solution here. So, I am just going to find out the crowding distance value for a particular solution. So, considering this inside, so we try to just draw one rectangle sort of thing, and then the side length of this particular the rectangle we just go on adding, that will be the crowding distance value. Now, it is obvious the points which are there at the end. So, there the crowding distance value will be much more, and the points which are very close to each other, the crowding distance value will be less. Now, during the reproduction, so we will have to give more weightage to the points whose crowding distance value is more. By doing that, so we will be able to maintain the diversity of this particular the solution. Now, then comes the concept of the intelligent optimization algorithm. Now, in short, let me tell you that this intelligent optimization tool is a robust optimization tool, which can tackle a variety of optimization problem, and its performance should not depend on the function. Now, we generally face some very complex real world optimization problem. There could be some uncertainty and imprecision in those particular the optimization problem also, and the problems could be dynamic in nature. And if you want to handle so those type of optimization problem, so you will have to go for intelligent optimization tool. That means, the tool should be intelligent enough just to take the decision as the situation demands. Now, what is the need? The need is actually, if you want to solve the real world problem in a more efficient way, so you will have to go for intelligent optimization tool. Now, how to achieve it? There are several ways, lot of work has been carried out, and lot of work is yet to be carried out to design and develop the intelligent optimization tool. There are several ways. For example, as I have already mentioned while discussing the visualized interactive GA, we can investigate the nature of this particular objective function. We can take the feedback from the nature of this particular objective function. Accordingly, we can give some search direction to the optimization tool. This is one way of implementing intelligence. There are some other ways. For example, we can design some sort of very efficient restart strategy for the algorithm. Supposing that I am running say GA for 1000 generation, might be after 20 generation there is no significant improvement. So, what you can do is you can restart this particular the genetic algorithm, and the intelligent restart strategies can be implemented. Similarly, we can design some intelligent operators like crossover mutation to make it more intelligent. So, there are several ways how to design and develop this intelligent optimization tool. Now, actually what we did topic 13, we took one practical optimization problem Now, the problem was very simple, and this particular the problem we formulated as a constraint optimization problem. First we consider as a single variable optimization problem, and we solved using all the techniques like your starting from the traditional and all non-traditional techniques. The problem was very simple. It was a very simple problem, like say I have got one this type of this type of single point cutting tool. So, this is actually the gripping end and this is the cutting end. So, the load is acting at the cutting end. So, there could be some failure on the cross section. So, how to ensure the safe optimal design of the cross section of this single point cutting tool. So, that was the problem. Now, to solve this particular problem, actually we tried to find out what should be the optimal value for this B and H, and the L is fixed and there is a load here P z is the maximum load, and let us see we will have to find out the optimal design of the tool, so that it becomes less in weight, but at the same time there should not be any such mechanical breakage. Now, to solve this particular problem, actually what we did, we took the help of all the algorithms which we have already discussed. For example, we first consider a single objective optimization problem, and we use all the techniques one after another, like we use random walk method, steepest descent, these two are the traditional method. Then we use non-traditional method like binary coded GA, real coded GA, simulated annealing and PSO, and we solved numerical example in details, and we have seen that these particular algorithms can be used to solve the problem very efficiently. Next, we formulated this particular problem as a multi-objective optimization problem, and we solved using the principle of DPGA and NSGA, and using NSGA too, like we could find out the Pareto optimal front top solution. Now, the last topic which we discuss, that is genetic algorithm as evaluation tool. Now, realizing the fact that we cannot design explicitly the different the things we want, we took the help of genetic algorithm just to evolve that optimal design. For example, in robotics we use like we try to evolve optimal motion planner, adaptive controller using the principle of this genetic algorithm based evolution. So, the same principle I am going to use here to evolve some neural network and your fuzzy reasoning tool, and here the purpose is actually to establish the input output relationship of a process using a neural network, and we consider the multi-layered feed forward network, and the purpose as I told just to find out the input output relationship. So, here I have got the inputs, here I have got the outputs, our aim is to find out the relationship, and if required, so we can actually derive the relationship in both the direction. So, we took the help of multi-layered feed forward network, whose performance depends on the connecting weights of these different layers of the network, the coefficient of transfer function of these particular your the neurons, and your the bias values, and of course, it depends on the topology. So, what we discussed, we kept the topology of the network fixed, and we tried to optimize the connecting weights, the coefficient of transfer function and so on. We took the help of batch mode of training with the help of a large number of iteration. So, corresponding to a particular GA string, say, so we get one multi-layered feed forward network, we pass all the training scenarios, a large number of training scenarios one after another, we find out how much is the error in prediction, we try to find out the average error in prediction, and we try to find out what should be the MSE, that mean squared error in prediction corresponding to this particular the first GA string. So, corresponding to each of these particular GA string, like we get the fitness information, then we use genetic algorithm to modify it, and ultimately GA will be able to evolve that particular the multi-layered feed forward network. Then we concentrate on how to evolve that fuzzy reasoning tool. The purpose is the same, to establish the input output relationship. The principle of fuzzy reasoning tool depends on the principle of the fuzzy sets, and here we take the help of the concept of the database and the knowledge base, the database and rule base, and considering both the things we call, that is called the knowledge base, that is KB. Now, the performance of the fuzzy reasoning tool depends on this particular the knowledge base, that means depends on the database and rule base. Database is nothing but the membership function distribution of the different linguistic term used to represent the variable, and the rule base actually relates the inputs and the outputs. So, all such information of the database and rule base we can put in the GA string, and in the whole population we have got, if there are n population size is n, we have got capital N number of fuzzy reasoning tool, and for each of these particular fuzzy reasoning tool following the principle of the batch mode of training. So, I can find out the fitness, which is nothing but the mean squared error in prediction. So, for the whole population we will be getting the fitness information, then using the GA through a large number of operators, it will be able to find out what should be the optimal the fuzzy reasoning tool, so that it can make this particular the prediction as accurately as possible. I should thank you all very much. Thank you very much for your patience, for your interest to learn this particular the course and this particular subject. I hope you have learnt a lot and you have enjoyed this particular course. Thank you once again for your interest. I wish you all the best. Thank you.